Welcome to the Midnight Files channel. On the night of August 15, 1977, something extraordinary happened in the quiet farmland of Delaware, Ohio. At the Ohio State University's Big Ear Radio telescope, a massive structure sprawling across 3 acres of grassland, a powerful radio signal from deep space was being recorded, but nobody knew it yet. The signal lasted for exactly 72 seconds before disappearing forever. It would take several days before anyone even noticed what had been captured. When astronomer Jerry Ehman finally spotted it while reviewing computer printouts at his kitchen table, he was so startled that he grabbed a red pen, circled the data, and scrawled a single word in the margin. Wow! That simple exclamation would give this mysterious signal its name and launch one of the most enduring mysteries in the search for extraterrestrial intelligence. The Big Ear Radio Telescope had been operating as part of the search for extraterrestrial intelligence, or SETI, program since 1973. The telescope worked in a unique way. Unlike modern radio telescopes that can be pointed in any direction, Big Ear could only be adjusted for altitude or height above the horizon. It relied entirely on the rotation of the Earth to scan across different portions of the sky. As Earth turned, different regions of space would pass through the telescope's field of view. This meant that any signal from a fixed point in space would naturally rise in intensity as it entered the telescope's beam, peak when directly in the center, and then fall as it passed out of view. This entire process for the Big Ear telescope took exactly 72 seconds. The detection system was automated. A 50-channel receiver monitored different radio frequencies, and an IBM 1130 computer processed the incoming data. The computer didn't produce graphs or visual displays. Instead, it printed out the signal strength for each channel using alphanumeric characters. The system used a scale from 0 to 9, then continued with letters from A to U. A reading of 1 meant a very weak signal, while U represented a signal 30 times stronger. Most of the time, the printouts showed random noise, a jumble of low numbers, and occasional letters representing the normal background radio emissions from space. Jerry Ehman was a volunteer astronomer working on the SETI project. His job involved the tedious work of manually reviewing these computer printouts, searching for anything unusual among pages and pages of data. On the morning of August 18, 1977, 3 days after the signal had been received, Ehman sat down with the printouts from August 15th. As he scanned the columns of numbers and letters, one sequence stopped him cold: CUJ5. This sequence represented the signal intensity rising and falling over 6 consecutive 10-second intervals. It started at level 6, jumped to E, then Q, then U, then dropped to J, and finally 5. The U in the middle represented the peak intensity, 30 times stronger than baseline. The pattern was exactly what you would expect from a signal originating from a fixed point in space as it moved through the telescope's beam. Without thinking, Ehman circled the sequence in red ink and wrote "wow" beside it. What made this signal so remarkable? First, its strength. This was not a faint whisper from the cosmos. This was a powerful, focused transmission. Second, its frequency. The signal was detected at approximately 1420 megahertz, right? Near what astronomers call the hydrogen line. This is the natural frequency at which neutral hydrogen atoms emit radio waves. In 1959, physicists Philip Morrison and Giuseppe Cocconi had published a paper suggesting that any civilization attempting to communicate across interstellar distances would logically choose this frequency. Hydrogen is the most abundant element in the universe, and its radio signature as well, known to any civilization advanced enough to build radio telescopes. It would be the cosmic equivalent of a universal language. Third, the signal was narrowband, meaning it was concentrated in a very specific frequency rather than spread across a wide range. This characteristic is typical of artificial transmissions and rare in natural cosmic phenomena. Most natural sources of radio waves emit across broad frequency ranges. A focused narrowband signal strongly suggested something other than random cosmic noise. The signal appeared to come from the direction of the constellation Sagittarius. When astronomers tried to pinpoint a more precise location, they encountered a complication. The Big Ear telescope used 2 feed horns, each pointing to slightly different areas of the sky as Earth rotated. The signal was detected in one horn but not the other. This created two possible locations for the source, separated by several arc minutes in the sky. The exact coordinates remained uncertain. The immediate question was obvious. Could this be verified? Astronomers aimed telescopes back at the same region of space, hoping to detect the signal again. They searched that night, the following nights, and repeatedly over the following weeks, months, and years. The signal never repeated. The Big Ear telescope itself continued, operating until 1995, continuously scanning the skies. Despite this extended observation period, the WOW signal was never detected again. This single occurrence presented both a tantalizing possibility and a frustrating limitation. If the signal truly came from an extraterrestrial civilization, why would they broadcast only once? One might expect a beacon designed to attract attention to repeat at regular intervals, like a lighthouse. The lack of repetition suggested either that the source was temporary, that it wasn't directed specifically at Earth, or that it wasn't artificial at all. Over the decades, various explanations have been proposed. Jerry Ehman himself initially suggested in 1994 that the signal might have been a terrestrial transmission that somehow reflected off space debris, creating the appearance of a cosmic source. However, he later reconsidered this idea. The requirements for such a reflection turned out to be unrealistic. The space debris would need very specific properties and be positioned in exactly the right location to create the observed signal pattern. Furthermore, the frequency of 1420 megahertz is in a protected radio spectrum reserved exclusively for astronomical research. Terrestrial transmissions are legally forbidden in this range, though occasional violations do occur. In 2017, astronomer Antonio Paris proposed that the signal came from comets. Specifically, he suggested that two comets, designated 266 Christensen and 335 P. Gibbs, had passed through the region where the signal originated, and that hydrogen clouds surrounding these comets could have produced the emission. This hypothesis was quickly dismissed by astronomers, including members of the original Big Ear research team. The comets were not in the correct position at the time of the detection, and more. Fundamentally, comets do not emit strongly at the frequencies involved. The comet hypothesis failed to explain the observed characteristics. The most recent explanation emerged in August 2024 from a team led by Abel Mendez at the Planetary Habitability Laboratory at the University of Puerto Rico at Arecibo. The researchers analyzed archived data from the now-defunct Arecibo Observatory in Puerto Rico. Between February and May 2020, Arecibo detected multiple narrowband signals similar to the WOW signal, though significantly weaker, and coming from multiple locations in the sky. These signals appeared to originate from small clouds of cold neutral hydrogen in interstellar space. Mendez and his colleagues proposed a fascinating hypothesis. They suggest the WOW signal was caused by a rare astrophysical event, a powerful burst of radiation, possibly from a magnetar or a soft gamma repeater, striking a cold hydrogen cloud. Magnetars are neutron stars with extraordinarily powerful magnetic fields. When they flare, they release enormous amounts of energy across the electromagnetic spectrum. If such a flare struck a hydrogen cloud at just the right angle, it could cause the cloud to suddenly brighten in radio waves through a process called maser amplification. A maser is similar to a laser, but operates at radio wavelengths rather than visible light. This would create a brief, intense burst of radio emission at the hydrogen line frequency. This hypothesis would explain many observed properties of the WOW signal: its strength, its frequency, its duration, and most importantly, why it never repeated. Such an event would require a precise alignment between Earth, the hydrogen cloud, and the radiation source. The chances of this alignment occurring again would be extraordinarily small. However, this explanation remains a hypothesis, not a confirmed fact. The research has not yet been peer-reviewed and published in a scientific journal. Some astronomers find the explanation compelling, while others remain skeptical. The hypothesis requires several unlikely coincidences to occur simultaneously. The Big Ear telescope had to be pointed at exactly the right patch of sky at exactly the moment when a magnetar flare struck a hydrogen cloud in just the right way to create a maser effect visible from Earth. While not impossible, some researchers question whether this explanation is more probable than other alternatives. Robert Dixon, who was director of the Ohio State Radio Observatory at the time of the WOW signals detection, offered his perspective. In later years, he noted that the signal's behavior strongly suggested it originated from beyond Earth's immediate vicinity. The way the signal rose and fell matched what would be expected from a distant cosmic source moving through the telescope's field of view. This characteristic made it unlikely to be interference from terrestrial sources or nearby satellites. Dixon acknowledged that without the signal, repeating definitive identification would likely remain impossible. The director of the Big Ear Observatory at the time, John Krause, wrote to astronomer Carl Sagan in 1994 stating, "The WOW signal is highly suggestive of extraterrestrial intelligent origin, but little more can be said until it returns for further study. That return has never happened." The Big Ear telescope was demolished in 1998 to make way for a golf course expansion. The SETI program that operated there had already ended in 1995. Modern SETI efforts have moved to more sophisticated facilities with better sensitivity and broader coverage of the sky. Projects like the Breakthrough Listen initiative use advanced machine learning algorithms to identify potential signals in real time rather than waiting days for manual review, as happened with the WOW signal. The WOW signal endures as a reminder of both the excitement and the frustration inherent in the search for extraterrestrial intelligence. It represents the kind of detection that SETI researchers hope to find: a strong, narrowband signal at a logical frequency, displaying characteristics that seem difficult to explain through natural processes. Yet it also demonstrates the challenges of this search. A single detection, no matter how compelling, cannot provide definitive answers. Without repetition or additional evidence, we're left with possibilities rather than conclusions. Was it a message from an alien civilization? Was it a natural astrophysical phenomenon we don't yet fully understand? Was it some form of terrestrial interference that perfectly mimicked an extraterrestrial signal? Nearly 50 years after Jerry Ehman wrote that single exclamatory word on a computer printout, we still don't know for certain. The WOW signal remains exactly what its name suggests: a moment of wonder, a tantalizing hint that somewhere in the vastness of space, something extraordinary might be waiting to be found. Or perhaps it's a humbling reminder that the universe holds phenomena we have yet to comprehend, events so rare and fleeting that we may glimpse them only once in a lifetime of searching. Please like and subscribe, and I'll see you in the next video. Thank you.